Okay, so now I want to do some examples to kind of learn more about shells. And I thought that actually first it would be really great to compare discs to shells. Now, the thing is it doesn't actually matter which one you pick. You should get the same answer. So I want to find the volume bounded by the square root of x equals 9, y equals 0. Rotate it around the x-axis both times. So that's going to create the same region. Okay, so it doesn't matter whether you use discs or shells. You should get the same answer. It's just going to look a lot different. So we're going to compare discs that we learned about earlier. We're going to do this with discs. We're going to do this with shells, and we're going to get the exact same answer. It's just going to look a lot different. Okay, so with discs, we've got y equals the square root of x. We've got x equals 9. And y equals 0, so the x-axis. And we're rotating this around the x-axis. Okay, it's going to create, I don't know, it's going to create this sideways, and it's going to be solid, because if we're rotating this area around and it's snug against the x-axis, it's not going to be a washer. That's why I didn't even mention that, but it's not going to be a washer because it's snug to the x-axis. Okay, so our little reference rectangle, you know, just an example of a disc, we're rotating this around, so it's going to go around the x-axis, come back, but it does create, you know, this washer. So we've got all these different washers in here with this infinitely small thickness, the height of the cylinder, which is a disc. Okay, so we've got all these different discs in here that we're adding up like a roll of quarters. Okay, is what they would look like. Well, the volume of this is your pi r squared h. Well, the pi we put outside, and then we're going to do this from 0 to 9. The radius of each of these discs is the square root of x. So it's going to be the square root of x, that's your radius, squared. So we've got, you know, we've got pi r squared h. Well, the weird thing about this is that the h for discs is your dx. Okay, so go ahead, pause the video, plug this into your calculator. You should get 127.23. Okay, now it's time to do the exact same thing, but using our new shell method. Okay, how does this make things any different? Well, same graph. Okay, and x equals 9 right there. So we're rotating this around, and it creates the same looking shape. Okay, but here's the thing. Instead of our reference rectangles being over here, they're perpendicular to the x-axis. For shells, they are going to be parallel to the x-axis. Okay, so we're still rotating around the x-axis, but here would be a shell. Okay, so it would look like that. Okay, that's one shell. There's going to be an infinite number of shells in here, so I'm going to draw a couple of them. Here's another shell. Its radius is actually a lot smaller. Okay, there's another shell. And another shell. So we're adding up this infinite number of shells. Its radius is bigger, but its height is smaller. Okay, there's all those shells, like a roll of toilet paper is what I compare this to. Okay, so the volume here, well, since shells are parallel, our reference rectangle now has a thickness of dy. Okay, so if I'm looking at this rectangle right here, the reference rectangle is parallel. We're going to have to do this in terms of y. So volume is, okay, so this is the first time we've done this. Well, it's 2 pi RH. So we've got 2 pi. We can move that outside. And then if we're doing this in terms of y, our original area is the same one that I shaded over here in red. And that goes from 0 to the x value 9. Okay, so if this is the x value 9, what's the square root of 9? This is 9 comma 3. Square root of 9 is 3. So we're going to go from the y value 0 to the y value 3. So those are totally different than the 0 and 9 we wrote over here, but it's for the same bounded area. 2 pi RH. So the radius of each of these shells is actually just whatever the y value is there. Okay, since we're doing this in terms of y, the radius is the y value. So y times, the radius is always going to be x or y, depending on the variable you're doing this in terms of. R is the y, the height. The height then is this x value. Okay, so the x value stretches, let's see, so the height is from here to here. The height is always going to start over here at x equals 9. So the height is going to be 9 minus whatever this value is here, which is the function in terms of y. So 9 minus the curve, which is y squared. So whatever the y value, whatever the x value is up until here. So 9 minus this piece right here would give you the location here. So 9 minus, so it's basically right minus left. So right is x equals 9 minus y squared. X equals y squared. So that is just right minus left. dy. Okay, so if you plug that into your calculator, so that's 2 pi r h, and then, so 2 pi, this is, let me write this in black above it. 2 pi, this is your r, oh, black, there we go. This is your r, this is your h, so that's the surface area, 2 pi RH, that's all the surface area, and then this is times the thickness. Okay, that's how you get volume, is by taking it times the thickness. When you plug this into your calculator, you should also get 127.23. So pause the video, take a second to do that. Okay, so when you do this in your calculator, you do have to, that's when you still have to use x's, okay, but the y's are on your paper. Okay, so I have one more example I want to do, and I want to do this one. I want to find the volume using shells of this bounded area, but I want to rotate it around different axes. Now, when you take a bounded area and you rotate it around a different axis, it's not going to be the same volume because you're creating a totally different three-dimensional figure. Okay, so x equals the square root of y plus 1, which is really, if I subtract the 1 and then square both sides, that would be y equals x minus 1 squared. So that's the parabola rotated 1 to the right. So it would be, where's my pen? Sometimes it. Sometimes it freezes. Okay, so there's that. And then it's also bounded by x equals 1. So I know then that I don't actually need the other side of the parabola because also we've got x equals 1 and y equals 4. So we're taking this area right here. Let's see, I don't want to use Use a highlighter to fill this in. So that area right there. And we're going to rotate it around the X and then also the Y axis. So if I'm going to take this and rotate this around the X axis, it's going to create this kind of, would that be like a bundt again? Kind of a bundt cake again. And we're going to use shells. So with shells, you want your reference rectangle to be parallel. So if I draw one example of a reference rectangle and I rotate that, I've got this shell right here. Okay, so let's try this. Since this is, so it's parallel to the x-axis, that means that this change is going to be a dy. Okay, so rotating it around the x means for a shell, I use dy. So volume is going to equal 2 pi. And so rotating it around so for the x-axis, for shells, that always means you're going to do the opposite variable, so dy. So volume equals 2 pi. So for y, we are going from the y value that is at 0 to the y value 4. Okay, so then 2 pi RH, R, the radius of this shell, is going to be, it's going to be the y value. And that's the way it always is. Your radius is always the variable you're in terms of. Okay, so then the height is what's a little tricky. So height, I'll highlight in red. There's your red. The height is right there. And so the height is going to be right minus left. Okay, so right is the square root of y plus 1 and then minus the left is x equals 1. Dy. Okay, so to go over this again, volume is 2 pi, got the 2 pi here, r, and then the height ends up having to be right minus left. Yikes. Okay. Now, when you plug that in, you should be getting 80.4 about. Okay, so that's the x-axis. I want to do the same region, but I want to do shells with the y-axis. So if it's shells and it's y-axis, that means we're going to do dx. Okay, so same region. X equals 1, y equals 4. Okay, and I'm going to highlight the region again. Okay, but if we're going to rotate this around the y-axis, oops, highlighter. This time, okay, shells are parallel, so my reference rectangle is going to look like that. Okay, so reflecting the region. Okay, so my shell, here's a shell. This is really gonna challenge there's one shell. Let me draw another shell in red. So here'd be another one. Not as tall, but actually wider. Okay, so the volume of this would be, now we're in terms of x, still 2 pi. And then in terms of x, that shaded region in terms of x goes from the x value 1 to the x value, oh, where do they intersect? I don't know if we figured that out. So the x value 1 to the x value, this is just a sketch. It looks like it's 4, but I feel like we better double check that. So I'm solving for when x minus 1 squared is equal to y equals 4. So if I take the square root of both sides, I've got x minus 1 equals 2, plus or minus 2. Oops, that's minus x minus, there we go, x minus 1 equals 2. So that would be when x is equal to 3. So I'm going from 1, the x value 1, to the x value 3. So my picture up here, it really shouldn't be, it should actually cross right there, not there. So my picture was a little off, but it goes from the x value 1 to the x value 3. That's just a good example of don't trust your picture. Maybe take the time to know for sure you know where they're going. Okay, so 2 pi r this time is going to be x, and your radius is always going to be the variable you're doing this with respect to. And then your height, in this case, since it's not flush with the x-axis, it's going to be top minus bottom. So top is y equals 4, minus bottom is x minus 1 squared. Parenthesis. And then your thickness, which is dx. Now, you should not get the same answer here. I don't have my answer written down, but this is a totally different three-dimensional shape. Okay, so you should not get the same answer here as you did above because they're not the same geometric region. But just showing you how, okay, if you take the same bounded area and reflect it around different axes, what it looks like and what the setup looks like. Okay, so your homework is, again, a worksheet. You've got to spend the time on this. What we just went through is not easy. You've got to do the work and ask some questions.